This is a worked solution to AQA Physics P2 June 2014 higher tier paper, question 4. This is the symbol for a thermistor, and the question goes on to ask us to calculate the resistance of the thermistor at 20 degrees. You can see from the diagram the thermometer is at 20 degrees and it gives us the current of 0.025 amps and the voltage of 9 volts. So moving on, the voltage and current and resistance are related by the equation voltage or potential difference is equal to current times resistance. So substituting those values in, 9 volts is equal to 0.025 times resistance. So if we rearrange that and divide each side by 0.025, we find that the thermistor has a resistance of 360 ohms. A thermistor's resistance decreases as temperature increases, and the graph should look something like this. Because thermistors can detect temperature changes, it would be used in a circuit to switch a heating system on or off. Ammeters need to measure current. If they had any resistance, they would reduce the current that flows. So ammeters have to have a very low resistance so they don't affect the current, or they affect the current very little. Question 4c describes the different temperature scales which are used around the world. Scientists use the same temperature scale because it allows us to have a common understanding of scientific developments, and it's easier to share results between countries so the scientists can compare them. So it gives a common understanding is fine as an answer. Or you could just state it's easier to share results or to compare the results. If instead of a thermistor, a student were to investigate the resistance of an LDR, which is a light-dependent resistor, some of the changes that would need to be made, obviously they would need to replace a thermistor with an LDR. An LDR depends on light level, and the components that you wouldn't need in the circuit we just had were the thermometer and the Bunsen burner and water. So you would need to replace the Bunsen burner with a lamp, because instead of temperature we're changing light level, and you would need to replace the thermometer with a light sensor, because we're now measuring light level and not temperature.